Maybe before we even go into the questions, maybe some of you would like to just give us an overview of general how the launches are happening, how launch rates in the industry right now are different from what has been there in the last decade, right? So who would like to take that first one?
Sure, I'll go.
Sure, Joel, please go ahead.
So what we see is we see a big step function in the number of launches that are occurring per year. And maybe more significant than that, a larger step function in the number of satellites launched. And so it's about small sats, rideshare, LEO, and big constellations. Keep in mind that as little as 5 years ago, 6, 7 years ago, the total number of satellites in Earth orbit was a single digit number of thousands of satellites, 3,000 satellites, something like that. And I remember serving on panels a few years ago. People were talking about, well, what's the launch rate going to be in the 2020s? And I was saying, well, you fully should expect 100 Falcon 9s a year. People thought I was crazy. I mean, I was like, people actually snickered at that. But like most people consider that we'll see 100 Falcon 9s a year. But then on the other hand, the launch rate of the small vehicles is really constrained by the market because of their cost per kilogram. So the really cool thing that's happening here is the total number of satellites in orbit 5, 6, 7 years ago was 3,000 satellites. Now we're getting that number of satellites launched into orbit every several months. And we're anticipating seeing north of 100,000 satellites in Earth orbit by the end of the decade. And that's very exciting. And what's driving this is elasticity in the market. We're seeing that new markets open up as cost per kilogram drops. And I think, and the way we look at it is that elasticity is going to continue, and we're going to see many, many new business models. And the proliferation of low Earth orbit, medium Earth orbit, we're going to see all kinds of new satellites in GEO, and then cislunar space. And so it's a very exciting time to be in the space business.
Perfect, thank you. And I see David is also sharing again the slide regarding the growth of the satellites deployed exactly to what you've been talking about, Joel. So, and a number is 107,000, which is just crazy, right? When we look at it. So,
yeah, I think exactly to Joel's point, if you look 10 years ago, not just an increase in the launch rates, but the number of satellites launched per year, that's really where we've seen the exponential growth. So we've gone from, sub 100 satellites per year to this huge step change where instead of, single large geosats being launched, we're seeing distributed constellations of satellites. And so there's that transition that's happening. You can almost think about it from like mainframe computers, massive computers that became decentralized personal devices. There's a somewhat similar trend in space where we're seeing these big communication satellites turn into distributed constellations. So there's a huge increase in the number of satellites launched per year. And then as Joel mentioned, we've seen a huge increase in the number of Falcon 9s launched per year because of that as well.
Yeah, and I agree with the analogy to to PCs replacing mainframes, and then you get many, many more PCs. But remember also that when PCs replaced mainframes, it also resulted in a lot more mainframes.
Yep.
And it also resulted in much more massive supercomputers. And so while we will see a proliferation in LEO of microsats, we also see a proliferation of new megasatellites on the other end. And as the payload capacity of Starship and New Glenn and some of the other super heavy vehicles start to hit, we're seeing engineers and entrepreneurs finding ways to make use of that, and new types of really massive platforms, both with humans in them and robotic platforms all over Earth orbit. So we see exciting things coming down the line.
Perfect, wonderful. So I feel that's a great introduction again for the panel, and thank you again for those points. So I think we're good to move into the next question here that I have prepared. Is what strategies are being employed to support the increasing demand for commercial spaceflight? So as we see, there's some of the companies which are really, again, stepping up their launch rates, and we're talking about SpaceX, Rocket Lab, and some others like Ariane Space as well, but which Ariane is not fully reusable just yet. What strategies are, again, being put in place to support this increasing demand for the satellites that are being launched and planned to be launched, as we're talking this 107,000?
Sure. So this is Kevin at Biospace. I think when we look at that landscape and we look at the number of launches that are going to need to be required to support the number of satellites that are going up, even if you figure that the large launch providers are going to launch 100, 150 times per year, that probably gets to 50 or 60% of the total capacity. Biospace is about 1,000 kilograms of total capacity. So if you look at our size class, the number of launches required to take up those additional satellites remaining is 500 in some cases, if you look at the math. So I think one of the biggest challenges is, not us getting to a launch cadence of one a week. It's the industry supporting from a launch location standpoint that number of launches. So we're working very hard right now, much like the satellite providers are looking to expand their capability across multiple launch providers. We're looking to do that across multiple launch locations to get to that kind of a cadence.
Perfect. And I think Negar wanted to add to that as well.
Yes. Sorry, I didn't want to jump on top of Kevin. And I think you make a really good point there. But I think another anecdote that I wanted to add about strategies that companies are taking to support the increased demand for commercial spaceflight. From the launch provider side, I would say offering customers a lot of flexibility has helped and supported the increased demand you see. And what I mean by that, for example, by flexibility is offering people the option to be able to rebook on future flights. So let's say they thought they were going to be ready to launch in June, but something happens with their supply chain or another event and they're not ready. And the launch providers now being very flexible with their customers and offering a very high cadence of flights. Often, in case of SpaceX, sometimes they have like weekly flights for their transport, for their rideshare programs, it's quarterly. So people don't get stressed. They're like, okay, we feel more comfortable booking with you now, knowing that even if I can't get on that flight, there's going to be another one in 3 months, and I can, pay a 10% fee or 20% fee and go in a couple of months. So I don't lose everything if I don't make it in June. And I think that reduces the barrier to entry and allows a lot more people to be able to sign on with these launch providers. So I think that's a key strategy, is offering the customers as much flexibility as possible in order to get more traction, more people comfortable with signing up with these kind of programs, such as the rideshare programs, in order to have the industry flourish. And I just gave you the rebooking as one example, but there's many other things in that nature that increase the flexibility to the customers that have allowed the industry to flourish in the way that we have.
Yeah, and I feel that's very important again for the, sorry, go ahead.
This is Nitish from Indian Space Research Organization, and I agree with the Negar's point that the flexibility is an important aspect. It has become an important aspect, and the government agencies have forced to become flexible in that sense. So, for example, for Indian Space Research Organization, we did not have a small satellite launch vehicle 2 to 3 years ago. But as the small satellite market is emerging, we have become forced to develop a small satellite launch vehicle as well. So we are in the process, and we have launched a developmental flight of that also. And that could not be fully success, but second one, we are very confident, and it's about to launch in few months from now. So the impact, the globally, whatever is happening, it is forcing launching agencies to adapt. And that is a significant change that I'm seeing.
Another thing that I would like to add to my pre-speakers is that launch companies should or start collaborating more and more with payload providers. And that's where Star Harbor comes to your help or to your rescue, because in this context, Star Harbor is leading the charge with the Lab to Orbit pipeline, which is set to revolutionize the way excuse me, small businesses, researchers, and space enthusiasts can launch their experiments into space. We act as an intermediary between launch providers and researchers, and we are streamlining the launch process and reduce the risk of failure, making space investment more accessible and attractive than ever before. So this is something that we are trying to bring to the table. Like we have all the launch providers, we have all the people who are interested in launching but don't necessarily know how to do it, and that's where we come and try to connect the two and make the process as easy and smooth as possible.
Perfect. And I feel that's very important. And as well, to finish my previous point, as I was commenting about what Negar said as well. So yeah, that's really important for the companies, that they can now book the flights, because the frequency is increased, that they don't actually have to have already their payload ready in order to book the flight. And again, they know that even if they will not be in time, for some reason, they can still manage to get a different flight as well a bit later with some, again, extra fee that they will have to pay. So the next question is, again, as we're discussing this increasing amount of flights, so how do the launch companies and launch providers balance, again, the need for safety and the efficiency and the speed of the launches that they're delivering, and how is that affecting the safety of the launches?
I have a thought on that as well.
Sure. David, would you like to go first?
Yeah, I think I only have really a quick point, which I actually see those things are actually kind of integral to each other, where when we have a higher cadence of launch, it typically correlates to a higher safety record. So if you look at SpaceX, I think it's the best example of it. They have an extremely high launch cadence, and because of that, they can really drill down on the process. They can optimize. They can push away risk. There have been examples, of course, in the industry where people have tried to ramp cadence before having reliability. I don't think that's the way forward. But in the case of SpaceX, for example, if you can build a reliable vehicle and then drive up the cadence, in their case, they're doing that with Starlink, which is having a broader benefit for the industry in terms of cadence, that inherently links to safety. And now they have a man-rated vehicle, right, which is essentially the highest class of safety within launch. So I don't think there's anything with high launch cadence that's drives down safety. And if you look at aircraft, for instance, we have a huge number of aircraft that are flying. That's a much more complicated problem in terms of collision avoidance than saying launching things into space. So that I think that would be my initial thought, is just there's a great opportunity to actually have much more reliable space flight when we're flying, many thousands of times per year in the future, versus kind of this early stage of space flight that we're still in, where there's maybe, kind of low hundreds of launches per year.
Perfect.
Yeah,
Andrew, please go ahead. Yep.
That's very much along the lines of the point that I was going to make. Back in the 20th century, we believed this thing that seems to be a lie, which is, hey, you get a choice. You either get quality or price, but you can't have both. Well, it turns out you have to have both. And you really don't get quality, you don't get reliability without cadence. And, this idea that you sit and study a problem and engineer the heck out of it on paper, and then occasionally go do something with hardware, that's just gone by the wayside. So the higher the cadence, the less the per unit cost, and the higher the reliability, as long as you have a competent organization. And what's exciting?
It's fine. Go ahead.
Oh yeah, absolutely. What's exciting is, up until now, the big revolution in space has been brought to us by reducing the cost of getting into space, and that revolution is just beginning. But the next revolution is starting, and that's the cost of getting around in space once you're there. Launch vehicles are super great at getting you into orbit, but they're not very good at taking you where you need to go once you're in orbit. And so the revolution of launch to space is full reusability and high cadence. The revolution of in-space transportation is in-orbit, reusable orbit transfer vehicles, where all you do is bring up payloads and propellant. And so that's why Transastra has been working on our breakthrough omnivore propulsion system that can use virtually anything as propellant. We're going to see propellant depots in orbit, and we're going to be able to refuel our vehicles in space and just pick up payloads and propellant. And that's going to be a big revolution. And so I actually think the projection of a little over 100,000 satellites in low Earth orbit is going to be low in this decade, because it takes it's a linear projection of what's been happening, and it doesn't take into consideration the next increases in cost effectiveness.
So from a Via Space perspective, safety is really one of the reasons that we exist as a company. We use hybrid engine technology to place satellites into precise orbits, and primarily because of the simplicity or elegant simplicity of the hybrid engine. We're about 1,000 fewer parts than our liquid bipropellant competitors, which just means that there are fewer things that can go wrong. I think it's a fair point to say that you don't want to get out ahead of yourself and launch at a cadence before you're able to, but we fully expect to pretty quickly be able to get to one a week, largely on the basis that we have such a lower part count than our competitors.
Perfect, thank you. And I would like to ask Ryan as well. So as we had his colleagues presenting on the previous days of the conference. So Ryan, can you tell us more how, again, the Spaceflight's partnership with some of the, again, launch providers enables companies to really find the perfect fit for their, again, launch and mission needs?
Right. So along the lines of what we were talking about with the flexibility earlier that launch providers individually were starting to provide more in the marketplace, the other side that customers and payload providers and developers of new space systems can really look to is flexibility across the entire suite of launch vehicles, and make sure that their spacecraft are enabled and ready to launch on any vehicle. That's something that Spaceflight historically has helped a lot of our customers do, is understand what they would need to do to fly on different launch vehicles and give them the kind of contractual flexibility to change launch vehicles when a particular launch on one would not work out for them. And then as Joel and Kevin were talking about the on-orbit transportation capabilities, our Sherpa vehicles that we've been developing and flying now are just that, trying to help establish that initial marketplace in low Earth orbit, trying to get those customers that are launching on these very frequent rides to space now, but aren't necessarily going to exactly the orbits they need to go to maximize their mission potential, and getting them to those actual destinations. It's going to optimize their return on investment for their vehicles. Whether or not they're going from LEO to something higher, or higher LEOs, going to MEO, going to cislunar orbits. We've been looking at doing drop-offs around the moon, going around the moon, coming back down to GEO to get to the higher orbits, where there's not quite as much rideshare opportunity right now with going straight to GEO, although we have done that in the past. Kind of bringing all that flexibility together, both on the launch vehicle side, which has been great, but making sure the customers have the kind of the heritage and understanding that they can tap into that allow them to work with any of the launch vehicles, I think has been very helpful for a number of players. And will continue to become more important when we start talking about the in-orbit transportation.
Thank you, Ryan, again for the overview. And I would like to ask Nitish as well. So how is ISRO again positioning now itself for launch services, as we've seen a commercial launch with the OneWeb as well from ISRO, and again the new launch vehicle that the ISRO unveiled. So what would be the ISRO's next strategy for the next 5 years or 10 years or the decade?
Thank you, Nicholas. So basically, ISRO was doing research and development activities. Along with that, ISRO was also having its own launch program. So that was quite burdensome. So we have tried to ease our burden by inviting private space industries within country and inviting a level playing platform for all the industries, which has decreased the burden from ISRO for launching. And we are trying to give the launch program to private industries, and ISRO is going to solely focus on R&D activities, much like the NASA has done for SpaceX. With this, we are going to focus now on more frequent science missions. For example, Gaganyaan, which is first maiden human mission of India, that is going to be placed by 2025 now. So this is the position that ISRO has taken, and it is not only giving a good platform to private space industries, but also generating revenues for ISRO because I remember Agnikul Cosmos and Skyroot, which are two emerging companies in India. They are using our test facilities, ground test facilities. They cannot really manufacture these test facilities on their own, but they can use, and they can we ISRO can generate revenue, and they get test tank facility for their testing their engines. So that is the road that looks like for ISRO.
Perfect. Thank you, Nitish. And the next question that I have, obviously, is one of the main themes for the conference is space sustainability. And I see some of the questions also in the chat regarding that. Some people are really, again, frightened by the number of 100,000, but we're not gonna really dive into that quite yet. What I want to ask, what are some of the technologies, again, green technologies, if we can call that? And I know that Viaspace is one of the companies that is leading on that front as well. So that are, again, what new propellants maybe and what new technologies are enabling, again, to minimize the impact of those new launches, either on the, again, atmosphere or on other aspects of the sustainability for the space activities. And maybe Kevin can start with that.
Sure. Yeah. Viaspace, again, is a hybrid engine company. So we have a solid fuel grain. Those solid fuel grains are made out of recycled plastic. It's high density polyethylene. So it's the recycled plastic for milk jugs, things of that nature. So every time that we launch a rocket, we'll be taking about 20 metric tons of recycled plastic literally off the planet. And every one of our launches, the primary emission coming out of those launches is water vapor and some CO2. So very, very minimal damage from an environmental standpoint relative to some of the competitors that we have, and taking plastic off the planet at the same time.
I could jump in there as well. So,
Sure.
so of course, spin launch is a alternative launch technology. If you look at the number of launches each year right now, the reality is that there isn't a huge impact as far as we can tell on the total carbon emissions from launch when you look at the big picture of global emissions. Where it is a little bit understudied is what happens in kind of these sensitive layers of the atmosphere where you're burning rockets. And of course, there are a variety of fuels as well. And so understanding how those different fuels impact, again, different layers of the atmosphere is, there's been research and study, but it's a more difficult area to really quantify the impact. And so, of course, as we get into thousands of launches per year in the future, then maybe there's a more and more meaningful contribution to total carbon emissions. Launch is very visible. You're burning a lot of fuel. It's a very visible, release of carbon into the atmosphere. But with a technology like spin launch, and not to be too much of a salesman on it, but the goal is essentially to be able to exit the atmosphere without burning fuel in the atmosphere, right? And so we're taking essentially the first stage of a rocket, which is 70 to 80% of a rocket, which only provides a small portion of the total velocity required to get to space. And then we're providing that with electricity. So we're going directly from electricity to velocity. And then essentially we have something that's much more similar to just the second stage, and that's burning primarily above the line of space. So there are, long-term, spin launch's goal is to provide alternative methods so that you can essentially eliminate the burning of fuel in the majority of the atmosphere with the launch system.
Perfect.
And I feel
Schwarzenegger has a point as well. Yep, go ahead.
I think you made a great point there, David. And I just wanted to add to it that in order to really get sustainability in space, we have to move away from the one-time use culture that we've had thus far. And you can already see some momentum in that direction when you look at some of the launch providers who are converting their upper stages into hosting platforms that they reuse in space, and they don't just leave them in their space junk or deorbit them. So essentially a future where all the launch vehicles create upper stages that can be reused for other purposes, either for in-space transportation, such as what Joel and Spaceflight and a lot of other companies are doing, or use them for hosting payloads and other applications, will definitely help with the sustainability of this industry and lowering the barrier to allowing more people in here. And And you know, another concept that I was exploring at the previous company I was working at was balloon launch, where you can take stratospheric balloons up and, you know, release the rocket there, which again, you know, to the point that David was making, reduces the amount of emissions in the upper atmosphere, which I agree with you, David, really needs to be studied more in terms of the net effect it has. So I hope going forward that these trends continue and that people start looking at ways to not use things once, but consider how to be able to recycle, reuse, refuel, and embrace satellite servicing and not think of it as a high risk factor, which will take both, you know, we haven't talked about this yet on the panel, but public-private partnerships, private investment, and the commercial industry all working together to really enable sustainability in space. And it can't just be the commercial entities pushing it or the government pushing it or, research institutes. So once everyone gets together and gets on the same page and view in embracing the fact that they want to reuse assets on space, they want to refuel assets on space, they want to service them in space, that's when we'll ultimately get to sustainability in space.
I like a lot of some of the things that the other panelists have said on this topic, especially when it comes to like reusability and like making the most out of assets that we're producing and putting into space, from the beginning. But I kind of want to bring this back to the top level for a second. We aren't actually looking to have a sustainable space industry right now. We don't want it to stay at this level. We want this to explode. We want it to grow. What we need to do in order to do that is we need to be profitable. We need to find ways to make money in space. The more money we can generate in space, the more like real investment that happens into real growing companies that have solid financials. That's going to get us the space industry of tomorrow that we're really looking for here and we're all trying to build. If we're not able to generate a profit, or if we're putting in lots of extra regulation in front of things to try to keep people from really expanding and trying new ideas, that could make it a lot harder for us. As we saw with like lots of other industries, early on, not every industry is like really, really easy to do with low levels of pollution until the engineering starts getting better. We have lots of great movements in those directions already, but I think we want to be careful and also remember that a real space industry of tomorrow doesn't happen without profit. That's really, we're not looking to be sustainable. We're looking to grow. We're looking to explode.
And just to add to all the speakers about sustainability, there are some options that currently going on and quite excites me are water electrolysis propulsion and green propulsion, which is based on H2O2 probably. So these are the two key areas where people are working and quite excites me and goes towards sustainability.
Yeah, in the long term, back in the 20th century, sustainability was about not growing. But in the 21st century, sustainability is about being able to grow exponentially and responsibly without harming the environment. And ultimately, space is the ultimate sustainability play for our planet. Transastra was founded with the vision of enabling humanity to harvest the resources of the asteroids. There's enough material in the asteroids to support a population of 1 trillion people spread throughout the solar system sustainably without damaging a biosphere. That's our vision. That's what we're working really hard to do. And we need to be sustainable in everything we do. So for example, we developed capture bag technology for capturing asteroids to harness those resources. But those capture bags, NASA right now is paying us to look at how we can use those capture bags to grab rocket bodies and defunct spacecraft in low Earth orbit. That's a sustainability play. Traffic management and debris management in low Earth orbit is critical. Likewise, we developed our Sutter telescope to find asteroids for asteroid prospecting, but it's the most powerful and cost-effective way to find moving objects in space, like orbital debris and spent rocket bodies, so that they can be cleaned up. So sustainability is about operating in a responsible way. I also agree with what David suggested. There are some concerns as our launch rates start to get up that we could be doing things like damaging the ozone layer. Humanity has come together to limit fluorocarbons, and the ozone layer is growing back, and it's much stronger than it has been in years. Let's make sure that nobody is using rocket propellants that can damage that. So I really salute companies like Stoke and Blue Origin that use LOX hydrogen propellants, which are just putting water vapor into the atmosphere. And it may also be in the long term, we may need to move most of our rocket launch operations to the equator where they're more efficient anyway, because it has less effect on the ozone layer. So I'm so glad you brought up sustainability, because that's what we're all here for.
Perfect, wonderful. So I would like to move to the next question, which is again the regulations and the licensing side of the things, which really sometimes tends to become a challenge, especially for companies that don't have like previous like heritage with the launches as well. So and we're seeing again with the established companies like Virgin Orbit in UK, how much time it took them to really get the license off and to get off the ground there. So what would be again how would be this regulatory environment evolving and changing to adapt again to the increasing launch rates? And what advices would you have as a panelist to those younger companies that are only now getting into the regulatory side and just now developing their launch vehicles?
So SpinLaunch has been working with the FAA for quite a while now. We have a good relationship with the FAA, and SpinLaunch is building a system that ultimately should be able to launch thousands of times per year with a single accelerator. And so you can imagine the conversations were pretty interesting with the FAA about what that looks like, because it's essentially an order of magnitude or more than what they've typically been regulating. And so this is obviously specific with the US. I'd be really interested to hear the perspective on the Indian launch vehicles as well. But I think in large part, there's many reasons to think SpaceX, but on the launch side as well, they really did pave the way to make high cadence launch a more of a normal thing, and also made it so that commercial launch providers had a place in the regulatory space. So the FAA essentially got a mandate to actually support disruptive launch technologies, commercial launch technologies. And so we've been perhaps surprisingly welcomed with open arms from regulators because they see us as fitting into that mandate. So there are things you have to think about. Of course, in the case of SpinLaunch, for instance, we're building a new type of launch system entirely. We optimize for looking at launch locations that really have very limited impact on local populations, or we're looking at launch sites that are very remote, have limited air and sea traffic, to essentially ease the burden on regulators. But I will say, from my perspective, I was really impressed with the FAA's ability to regulate a company like SpinLaunch and not have to develop new regulations, but actually find a place for us to fit within them. And again, SpaceX, I think, did the heavy lifting. There was other companies that tried and failed previously, but that transition from government launch vehicles only to commercial was a big deal, so that future generations of launch companies could have an easier path to the regulatory space.
I think that's very well said, and I would agree from a Viaspace perspective. The FAA has been very cooperative, and the one thing that we've noticed over the course of the last, say, 6 or 8 months is the Space Force and FAA have started to communicate and be more cooperative themselves, so that we're dealing with really one regulatory body, or essentially one regulatory body instead of two. So there's a lot of progress that's been made on that front. And then the other place where we're seeing pretty good traction is we're working with a company called the Spaceport Company for mobile offshore launches. And the FAA has been very responsive, working with both of us to make that happen. So we're pleased. And I would say that over the course of the last 6 to 9 months, the communication and the interaction has just gotten much better.
Perfect, wonderful. And again, both Kevin and Joel again touched upon the importance of the spaceports as well. And what role do spaceport development play in supporting again the launch rates and increasing launch rates as we have now more companies and more locations that are trying to, and more countries that are trying again to reach space, right? So how does the spaceport development play a role in that?
From Indian perspective, we had a launch port at Sriharikota, and from there we had to go doing a dogleg maneuver crossing Sri Lanka, because Sri Lanka was just behind India. So the second satellite launch vehicle that we are developing now, SSL, we have chosen a location from where we will be able to go to the equator in a straight path. So first is this one, fuel consumption minimization is the most important criteria. Then the coastal launch ports are preferred mostly due to the lower risk for the people and all. So these are the two things that generally, and many other factors as well, the transportation, the land transportation, the sea transportation, and all these factors come in for selecting a space launch vehicle site, basically.
Perfect, thank you. I see we're nearing the end of the panel as well, and that's sad because we could go literally on for another hour probably and discuss again the full details of the launch services and how again the industry can support that. But for the last question, I think it will be good to discuss again how can the industry ensure that the launch services become accessible and remain accessible for emerging commercial space companies and emerging countries for the space industry? Whoever would like to go ahead with that.
It's all about, look, to make the services accessible, we need to make sure they're not over-regulated and that the private sector is providing great goods and services in a competitive environment. One of the things that the market has shown us recently is it's not enough to have a nifty concept. You have to have a cost-effective solution. And that comes from good system architecture, good business models, and good planning. And companies that are doing that are succeeding, and companies that are sticking with things that don't work aren't. So I'd say let's make sure that we're promoting great entrepreneurs who serve their customers.
I think another thing to kind of get maybe into the weeds a little bit more is for the launch vehicle side, being very clear about your requirements, having those things published out so that the market can see them, even if they're not directly engaged yet, but have that information out there. And then try to keep those really stable so that businesses that are planning new vehicles know what to build to and know they can rely on those sets of requirements so that they don't have to worry about the ground shifting out from underneath them when they are finally ready to launch that vehicle they've invested millions of dollars and multiple years into developing. I think that is very helpful for keeping it accessible and allowing companies to make sure they understand what they're going to be working with as they go out and actually try to test their business.
I think that Ryan, oh, go ahead. Go ahead. I'll jump in after.
Okay, sorry about that, David. So I just wanted to piggyback on what Ryan was saying. And I actually think that launch testing and qualification has been one of the greatest barriers for a lot of the new space community and a lot of new entrants, because these people come from other industries and have no idea how to space qualify things. And having the launch providers and aggregators such as Spaceflight, Transastra, etc., offering those services to their customers in order to ease the barrier, I think is critical. And I'm glad to see most of the aggregators and in some cases, the launch providers offering that. So not just saying, here's a list of all the requirements that you need to meet. But in addition to that, I have this Vibe facility that we can use, and we have experts in this testing that can help you with conducting the testing and getting the results done, or any other testing that's required, such as thermal vacuum. Because in order for us to really proliferate and open access to all, you have to open it up to people who have never been to space. The pharma industry, the marketing industry. Like a great example is, we were in one of my previous companies, we were working with a doll manufacturing company that wanted to send dolls to space and had no clue that, oh, I can't send this piece of plastic to space. It's going to outgas, etc. So having entities that partner with the new entrants into the space ecosystem and showing them the ropes on what you need to do in order to get to space, I think is critical to make it more accessible.
I would add, and this is kind of in line with what you were just saying, there's been a big barrier in terms of going from idea to actually have something in space, and in large part that's because of testing and qualification and not understanding the demands of the space environment, from radiation to outgassing, and what it means to have reliability and longevity in space. Components are way too expensive right now. Satellite systems and components are really incredibly expensive. And even though it is a tough environment up there, there's a big opportunity to significantly reduce the cost of space system components. And so something that Spin Launch is doing, other companies are doing this as well. There's a number of launch companies that are doing this, is building lower cost components so that customers who have an idea and have an application can worry less about navigating, again, radiation design, for instance, and focusing on actually the application that they care about. So I think we're going to see an increase in essentially turnkey solutions, so that a customer that has a payload, say they have some unique synthetic aperture radar technology that they've developed and used in terrestrial applications, they want to put it in space, they can leverage satellite buses and components so that they focus more on just the application rather than all the complexity of actually putting something in orbit. And that's, again, where aggregators are really great. You have a single point of contact and you can move across different launch providers and get there easier.
Yeah, that's what a lot of the OTVs are looking to do as well, like our Sherpas hosting those payloads, that they're just trying to focus on that one piece of technology that's going to prove their business plan. And we can put it on our bus, on our vehicle, have the propulsion on board to bring it down at end of life, and maintain that sustainability, but get that customer up there at a much shorter turnaround time than they would otherwise do if they had to build their own bus.
Yeah.
I think all of you brought up really good points, and I can speak a little bit from a more of a customer perspective. And I think that streamlining the process of getting yourself to orbit and your experiment to orbit and your technology to orbit is really critical, because if you're on the other side and you're paying a lot of money and you're inventing technology or planning your experiment, you really are spending a lot of money, so you expect a good return on your investment, right? So having this know-how, lessons learned, or like common base of knowledge that everybody can use and utilize to improve their success rate would be very critical for the growing commercial space sector.